In this video, I'm going to show you how to use substitution to solve a system of two linear equations with integer coefficients. But before we get into the method of substitution, let's first acquaint ourselves with what we're working with. Let's first verify that this point 1, 2 is the solution to the following system of equations: 2x plus 3y equals 8 and 5x minus y equals 3. So to be a solution to the following system of linear equations, that means when we plug in this point, when we plug in 1 for x and 2 for y into both of these equations, both of the equations should be satisfied. So let's check that. Let's plug in 1, 2 into both of these equations and make sure they check out. Okay, so first equation is 2x plus 3y equals 8. And now let's write that again, but substituting 1 for x and 2 for y. 1 is x, 2 is y. Okay, so this first equation becomes 2 times 1 for x, and then plus 3 times 2 for y, and that is supposed to equal 8. So let's check. Does that work? Well, we need to evaluate the left side here. So 2 times 1 is just 2, and then plus 3 times 2 is, well, see, 3 times 2 is 6, and then that has to equal 8. And 2 plus 6 is 8, and yeah, that equals 8. Nice. So that checks out. That tells us that this point here is a solution to the first equation here. That's good. But in order to be a solution to the system, it also has to satisfy the second equation. So we also have to check the second equation. So let's do that just like we did with the first equation. Now we've got 5x minus y equals 3. So 5 times x, we're substituting in 1. So 5 times 1, and then minus y. So minus y is being replaced with 2. So minus 2, and that is supposed to equal 3. Okay, so let's check. Does this indeed work? Well, let's evaluate the left-hand side. So 5 times 1 is 5, and then we're subtracting 2. And when we do 5 minus 2, is that equal to 3? Well, yeah, 5 minus 2 is 3. And the equation then checks out. So that means the point is a solution to the second equation as well. And because it is a solution to both, it is the solution to the entire system. Great. So yes, 1, 2 is indeed the solution to the system of equations. Okay, so we know how to verify that a given point is a solution to a system of linear equations, but what if we weren't given any point? How would we find the solution if we weren't already told what it is? Well, we'll discuss a method here called substitution that allows us to do this. Here's an example where we want to solve the following system of linear equations. We've got two equations. One is y equals 2x plus 7, and the other is x plus y equals 1. So we want to find a pair xy that satisfies both of these equations. And we're going to do this using the method of substitution. Substitution just involves substituting for one variable in terms of the other variable to construct an equation that just contains one variable. Right now, both equations have two variables, but one of them is solved for y. One says that y is equal to 2x plus 7. So if we take this value of y equals 2x plus 7, and we substitute that in for that value of y in the other equation, then we'll get an equation that just has one variable, and then we can solve it. So let's go ahead and do that. We'll substitute in, and then the result is we've got x plus y, and instead of y, we're going to be writing this expression here, 2x plus 7, because we know that has to be equal to y. So x plus 2x plus 7 has to be equal to 1. And now this is an equation of a single variable, and we can use regular algebra techniques to solve this. So first of all, let's group up all the like terms. So here we've got an x and a 2x, and we can combine this. This is like 1x, so 1x plus 2x makes 3x. And then 3x plus 7 has to equal 1. Okay, so we want to isolate this x alone. So we need to get rid of the 7. We can do that by subtracting 7 from both sides. So minus 7, and what's the result there? Well, 7 minus 7 cancels out, and we've just got 3x on this side, and then 1 minus 7 is negative 6. Okay, great, we're almost there. So we've got 3x equals negative 6. We need to get that 3 off of the x, and right now the 3 is multiplying the x, so to get that 3 off of the x, we can divide by 3. So if we divide by 3, then that'll cancel out the 3 here, and then we'll just have x is equal to negative 6 divided by 3, and that is just negative 2. So there we go. So x is negative 2. That's the first part of our solution. We also have to find the value of y, but we know that x is negative 2. Okay, so we'll put some stars by this because this is super useful. X is negative 2. Now, how do we find the value of y? Well, now that we know that x is negative 2, we can plug that into one of these equations to figure out what y is. We could really plug it into either one, but just because the first equation is already solved for y, we can just plug in negative 2 for x there and then compute. Let's use that one. So y is equal to 2 times x, and we know from here that x is negative 2. So 2 times negative 2, and then plus 7. Okay, and then we just solve that, and so then we get y is equal to 2, or let's multiply this out. Y is equal to 2 times negative 2 is negative 4, and then plus 7. So then y is equal to negative 4 plus 7, which is like 7 minus 4, which is just 3. Great, so there is our other solution. So we can combine these two solutions into an ordered pair of the form x, y, and x is negative 2, and y is 3. So there we go. So there is our solution to the system. This ordered pair should satisfy both of these linear equations. And in order to check that our solution is indeed correct, we can do what we did in the previous example. We can just verify that the solution satisfies both of these equations. So the first equation, why don't we let's draw a little line here to divide our checking work. Our first equation is y equals, write it here, y equals 2x plus 7. And now when we plug in this ordered pair, x is negative 2, y is 3, what does this equation become? Well, this equation, y is 3, so sub in 3 for y. That's equal to 2 times x. X is negative 2, and then plus 7. And does this work out? Well, 3 equals 2 times negative 2 is negative 4, then plus 7. And then 3 equals, well, negative 4 plus 7, that's like 7 minus 4, which is 3. So yeah, that works out. So this ordered pair does indeed satisfy the first equation. Okay, how about the second equation? It also has to satisfy this x plus y equals 1. So let's write that down here, x plus y equals 1, and let's substitute in our x and y from our ordered pair. So x is negative 2. All right, put that in for x, and then plus y is 3, and that's supposed to equal 1. So negative 2 plus 3, that's like 3 minus 2, which is just 1, and yeah, that's equal to 1. Great. So that checks out, and that means that our ordered pair also satisfies the second equation, which means it is indeed a solution to our entire system. Here's another example. We want to solve the system of linear equations 2x plus 3y equals 8 and 5x minus y equals 3. And this is actually the very first example that we did. We verified that 1, 2 is the solution to the system. So we already know the solution, but let's use substitution to find the solution. When we use substitution, we should come out to the same exact solution that we had earlier. So let's do that. Okay, so how do we use substitution to solve this system of linear equations? Well, it's a little bit harder now because in the previous example, we had one of the equations already solved for y, and then we could just plug in that expression into the other equation. But now we don't have either of the equations solved for y. But there's a simple fix to that. Let's just solve one of the equations for y. Do we want to solve the top one for y or the bottom one for y? Which one looks easier? I think the bottom one looks easier because we don't have any number multiplying the y. So it'll be pretty easy to isolate y. So let's take this bottom equation. Let's write it out here. Write it out. 5x minus y equals 3. And let's solve this equation for y. So why don't we let's just add y to both sides to get the y to the other side, and then we can subtract the constant. So just add y first. So plus y. All right, so y cancels out there, and then we've just got 5x equals 3 plus y. And then to get the y alone, we can subtract 3. So minus 3, and the result of that is just 5x minus 3 is equal to y. Okay, so this is our expression for y in terms of x that we can substitute into the other equation to get a single equation with a single variable. So let's do that. Let's write down the other equation. The other equation was that was 2x plus 3y equals 8, and now this expression for y is going to go into that variable y in the other equation. And the result when we do that is we get 2x plus 3 times that expression for y. So times 3 times 5x minus 3 is equal to 8. Okay, and that is an equation that we can solve. So let's just go ahead and solve it then. Let's move it over here so we have a bit of space to work with. Okay, so 2x and then plus 3. So 3 is distributed over this difference here. So first of all, 3 times 5x, 3 times 5 is 15, so 15x, 2x plus 15x, and then 3 times negative 3 is just negative 9. So put a minus 9, and that is supposed to equal 8. Alright, so now let's solve this equation. That's a lot simpler. We can combine like terms here. There's a 2x and a 15x, and we can combine that into 17x. And then we still got a minus 9 is equal to 8. And how do we get rid of that minus 9? Well, we just add 9 to both sides. So plus 9, okay. And then these minus 9 and plus 9 cancel out. And we just got 17x on this side, and then 8 plus 9 on that side. So 17x equals 17. And then how to get rid of the 17? Well, just divide by 17. And the result is just that. X equals 17 over 17, which is just 1. Okay, great. So we've got one of the variables here. X is 1. And then how can we solve for y? Well, we have an equation that tells us what y is. Y is just 5x minus 3. And we can just plug x is 1 into that equation. So let's do that. So let's write that here. Y equals 5x minus 3. And we're going to plug that x equals 1 into the x there and figure out what y is. So when we do that, we get y is just equal to 5 times 1, then minus 3. And the result of that is just y is equal to 5 minus 3. 5 times 1 is just 5. 5 minus 3. And then we've just got y is equal to 2. There we go. So that's our solution for y. And putting these two solutions together, we get the solution of the entire system. That is the ordered pair. X is 1 and y is 2. So there we go. There is our solution, and yeah, that matches up with what we had earlier. We already knew it was 1, 2, but this time we used substitution to figure that out. Here's a final example. We've got another system of linear equations that we want to solve. And this system is going to be a little bit more challenging because again, we're going to have to solve for y in one of the equations. But in both equations, solving for y is a little bit complicated. But that's okay. We'll just get down to it and it won't be too bad. So why don't we pick an equation, how about the one that has smaller numbers? Smaller numbers are usually nicer. So how about this top equation? Let's take that top equation and solve that top equation for y. So write that top equation down. Negative 2x plus 3y equals 3. And we want to solve that top equation for y. So why don't we get rid of the x on that side? So how about plus 2x on both sides? Plus 2x and plus 2x. And then the result of doing that is the negative 2x and the plus 2x cancels out. And we've just got 3y equals 3 plus 2x. Okay, now we just want to get the 3 off of the y. How do we do that? Well, the 3 is multiplying the y, so divide by 3 to cancel out the 3, and divide this side by 3, and the result of doing this is we just get y is equal to 3 divided by 3, so 1, and then plus 2 divided by 3x. So like 2x over 3, or just 2/3 x. Okay. So that's the equation that is solved for y, and we're going to take this equation and substitute it into our second equation here. So let's do that. So let's write down our second equation here. Second equation, to give us some space, why don't we write it down up here? So negative 7x minus 6y equals 5. And now we're going to take that y and plug it into the y here. And we're going to write it in terms of x. So that way we get a single equation with a single variable that we can solve. So this equation becomes negative 7x minus 6 times y. Y is just, according to this equation, is just 1 plus 2/3 x. And that is supposed to equal 5. So let's go ahead and solve this equation then. So what does this equation simplify to? Let's distribute that minus 6 over the sum here. So first of all, so negative 7x, and then minus 6 times 1, so just minus 6 still, and then minus 6 times 2/3 x. Let's just write down that whole thing, minus 6 times 2/3 x, and we'll deal with that in the next step. Okay, so that's equal to 5. Okay, so negative 7x minus 6, and now let's simplify this part. So minus 6 times 2/3, well, this is like, we can cancel out that 3 and cancel out the 6 to become a 2, because 6 divided by 3 is just 2. So 2 times 2 is 4, so this is really minus 4x. You could also think of that like 6 times 2 is 12, then divided by 3 is 4. Either way, you get to 4. And that's equal to 5. Okay, now let's tidy this up a bit. So we've got a negative 7x, and we've also got a minus 4x. So this negative 7x and this minus 4x, if we put that together, if we do negative 7 minus 4, we get negative 11. So negative 11x minus 6 is equal to 5. Okay, now we just want to get the minus 11x on its own. So add 6 to both sides. And the result of that, this cancels out. Negative 11x is equal to 5 plus 6, which is 11. Okay, and then finally, to get x alone without any constant multiplying it, we can divide by that constant. Divide by negative 11 on both sides, and result is negative 11 cancels with the divided by negative 11. We've just got x is equal to 11 over negative 11. And 11 over 11 is just 1, and then there's also a negative sign, so So -1. Okay, so there's our solution for x, and now we can go ahead and plug that into the y equation that we solved for. So let's do that. So plug this -1 into that y equation here. So take that and put it in for the x there, and the result there is that y is equal to 1 plus 2/3 times -1. Okay, so that means y is equal to 1 minus 2/3. And okay, so how do we subtract this fraction from this whole number? Well, why don't we start by turning the whole number 1 into 3/3 to get it to have the same denominator. So now that's 3/3 minus 2/3. Now that they have the same denominator, we can just subtract the numerators and get y equals just 3 minus 2, or 1/3. So there's our solution for y. And now both of these solutions go into our final solution of the system, which is just -1 for x, and y is 1/3. Okay, great. So we're running out of space here, so we're not going to check the solution, but I would encourage you to check it anyway, just because it's good practice. And it's easy to make mistakes while doing all the algebra. Once you check it, you know that you've done all the substitution right, and you've got the correct answer. Now, in these examples, the coefficients of our linear equations were all integers, which made it relatively easy to perform substitution. However, in the future, we'll also practice substitution on trickier systems, including fractional and decimal coefficients.